Ladies and gentlemen, after all these years we finally have an ARC. And by ARC I mean we have a 1080 Ti. Ta-da! Yeah, I got it. I almost got clickbait by this box by myself when I opened it up. And then I thought, man, I really wanted to take a look at this card, see what it's all about, and get that Intel shame exposed, if there's any. So let's clear our mat real quick with some alcohol, and we will begin fixing this beauty of engineering by EVGA. Okay, so the customer stated that the card is a no detect. What do they mean by no detect? No idea. Let's measure resistance on 12 volt. Good here, 3.3. Nothing there. No short circuits. I think we can probably access PEX with 80 ohms on PEX, which is good. I cannot see 1.8 coil, probably somewhere up on top there. Can I access 5 volt rail? I do not think so. Okay, let's go in the back, and I think up there we have a couple of more inductors that we could poke at. What is this one here? That was PEX, that was memory, so that was perfectly fine. I did not get a chance to measure this one here. That's probably 1.8 volt. So let's measure that real quick. No short there. This here's probably 5. These are probably 12. Or they might be 5 too, I don't know. But there's nothing on there, so no shorts on 12, and I think we're good. So let's check the first pair of the data lines just in case, so that we know that our core isn't falling off. So the core is completely dry. There's a lack of thermal paste, a little bit, or maybe not. And then on the back, there we go. Oh, look at all that beauty. On the back, check first data pair, 4 or 5, about the same. Clock reference, about the same. PEX reset, in reverse. Okay, so we have everything. And by everything I mean we have everything we need in order to fire up this card and not to worry about it blowing up. So let's power it on through my Super Mega Pro Tester XL. This guy. If you want to learn more about this tester, please scroll down to my previous videos and you should be able to find it. Okay, so let's see if we get any voltage rise on this card. And all we have to do is to look at this number here, and if it says that we have nearly 0 amps, that means we're probably missing 5 volts. So let's see if we have 5 volts. We do that by using the multimeter. Obviously, we can't do it using a fork. So let's see if we have 12 volt coming in. Okay, 12 volt there. 12 volt there. Do we have 5 volts? Oh, that's 12 volt. I'm sorry. My mistake. What about here? Oh, 5 volt there. What about here? Some kind of a 0.3. So I think we have a problem right there. So if we were to look at what causes the problem, there's a little tiny buck converter right next to it that we can take a look at under a microscope and investigate. Alright, so this is the buck converter that we have there. The way we want to diagnose this is we want to see 12 volt coming in we want to have enable power grid signal, and eventually it will give us 5 volt coming out. So the way we figured out what pin this is we can look at this board view that is completely different from this from the board that we're working on, but it doesn't matter. The pin out is going to be the same. So we're supposed to have 12 volt on the pin number 2. Then we want to have some voltage on pin number 6, which would be enable, and then ultimately pin number 3 is going to give us the phase. Okay, so we want to see pin number 2 and 12 volt, and we want to see pin number 6 enable signal. So let's go under microscope and check it out real quick. All right, pin number 2 is going to be 1 and 2. Let's see if we have 12 volt on this pin. We have 12 volt on this pin. And then now we need to check pin number 6. So 1, 2, 3, 4, 5, 6. That should be enable. We have 3 volt, which means we do have an enable signal. And if we look at the pin number 7, I never bothered to look at this pin, but let's take a look at it. 0.3 volt. So I think we have our diagnosis. We have the enable. We have this 12 volt coming into the chip. We have enable signal present, and for whatever reason, this chip is not generating desired voltage. And so with that said, all we have to do is replace this chip as a first step. All I gotta do now is to find where I keep these chips. Okay, so I've already replaced this chip. Unfortunately, I didn't hit the record button. But I mean, what's so special about replacing a buck converter? Absolutely nothing. So we might as well not even bother documenting anything in that regard. Just let the board cool, clean it up. Yeah, that looks good. All right, let's see. Okay, let's see if we can get any better situation in terms of our power draw. So let's go ahead and, well, first let's measure that we did not short the 5 volt rail. Looks like we did not. I wonder what the resistance is. 4 kilo ohms, something like that. Looks about right. Now let's see if we have any better current draw. 1.2 amps, which means we probably have, where's 1.8? 1.8, we must have gotten core. Yep, there's core, which means we got hex and memory. All right, I think this repair is done. All I gotta do now is to partially assemble it, plug it into a computer, and see if it runs. The core itself looks very good. Very grayish compound around the core, around the crystal, indicating no abuse, which is good. Alright, so let's run a memory test at the same time. Let's see if we can get that done. Alright, it's a healthy beep, but no image. No image. Why do we not have an image? Did I forget to plug something in? I don't know. So that's there. The HDMI is there. Maybe HDMI is rusty. Let's try DVI. Okay, I'm gonna try DVI cable here. Let's try DVI. Still nothing. Okay. Okay, we have a new symptom.
It's a new symptom. Neuropathy.
So let's go ahead and probably boot into... Let's see if I have an image coming out of the built-in graphics adapter. Because if I do, then that means this card is definitely not detecting. Alright, so there we go. So it looks like the fact that I booted from here is already an indication that we are not going to boot, we're not detecting this card. So let's see if I can boot into a USB drive, and then from there you will see that it is actually not detected. Oh, why did I do that? I don't know why I just did that. I forgot to click something. Alright. Well, while we're here, might as well open a device manager, and there we do not see our device. Basically, because it's not there. Just giving it a second. Yep, it's not there. See, if I open a GPU-Z, we're not gonna find it there either. So, what are the common reasons for this not to be detected? See, no card. What are the reasons for something like that to not work the way you expect? We have a no detection situation, and so yep. So all the phases are there. I just real quickly checked, which means we are probably having an issue with a PEX reset logic. Okay, let's address that issue. That issue is probably located on the back of the board, which means we're gonna have to remove this. Ugh. This yuck. See if I can remove this without tearing anything. Okay, so I was looking around at this board view here that I thought was supposed to be matching, but nothing ever matches. And it tells me that the PEX reset logic is here right above the slot. That is not true. And I also looked at the other board. It actually points it out at the bottom here. That isn't true either. So what we're going to do is we're going to do the good old method of finding where the PEX reset line is. And we do that by using our multimeter with the beep mode. See, it beeps. Okay, so what we'll do is we connect one end to the brush, the other end to the PEX reset pin, and we start brushing. Oh. Alright, bingo. Okay, so I think we found it here. And why do I even bother with this? Now let's go ahead and switch over to the microscope, so we can take a look at what we found. Let me see if I can focus in here, right there. And I will switch to microscope so that we can look Let's double check. Let's double check. Is that the one? Which one is it? Ah, this one. So it's the middle pin. Okay, so it's the middle pin of this guy. So what I want to see is one of these pins is ground. So which one's the ground? Let's see if I connect black lead to the ground. So this one's ground. So I want to see voltage here, here, and here, and ultimately voltage that will be on this pin is going to be coming from the motherboard. So in order for me to test this particular thing, the card should actually be plugged in into a computer, because otherwise that PEX reset signal will not generate any voltage on there whatsoever. So a little bit of inconvenience, but we don't have to power the whole card, just the slot. Although we might. It depends on how the circuit is built. I don't know. So I better be safe than sorry. And I will plug in both of these connectors if I can. If I can. There we go. Let's see. Now, I am running into a little dilemma of keeping the core cool while doing so. One way I could do this is temporarily assemble the core. Temporarily assemble the cooler so that it's safe to perform this test. And I will see. Am I connected? Yes. Okay, so let's power on the board, power on the computer, and I want to see if we have 3.3 on this. Yep, we do. Obviously, we don't have anything here. Oh, we do. Okay. So we have power coming in here, and we have power coming in there. So that's good. Those are inputs, I think. And then the output 1.8, and then this one. So these two, they both have voltages, which means the PEX reset logic is working, which means the problem is not PEX reset, but rather something different. Okay, so maybe today you learn how to check PEX reset logic. Alright, I'm back. I do have to apologize that I did not record everything I wanted to record, but once I figured out what was wrong with it, I would like to show you. And as you can already see, I'm pointing at this frequency generator. This is the oscillator. The oscillator has 4 contact points, but only 2 are connected to the GPU. So if you were to probe conveniently, there are these 2 test pads here that you can. So if you probe these in diode mode, and then they both make connection to the core. But in any case, it's supposed to have 27 megahertz, and I only had like 300 hertz or something like that. And so I ended up replacing the oscillator. So if I plug it into the one of those pins there for testing, and I flip on the switch, we can see that we indeed do get 27.0 megahertz. And the other reason why I'm showing this to you, or rather how I was able to identify this particular problem, is simply by looking at the BIOS chip. Let's see. We have 2 BIOS chips on this board. This is a dual. So usually BIOS chip are indicated by some sort of a mark. So I'm gonna hit and reset my oscilloscope, and I will show you what I mean. So when I'm poking around the BIOS chip, I want to check the pin number 2 and pin number 6. So actually pin number 6 is going to be 1, 2, 3, 4, 5. Is it 6? I think it's 6. Data in. That's when the data. Well, it's not. I'm not going to see anything right now on that pin because the board is not powered to a computer. But let me go ahead and power it on. Let me go ahead and quickly and swiftly plug it in to a computer, and then I'll show you what I mean. Hang on. Almost there. Power cable here. Power cables tangling. Right there. You can feel the excitement in the air. All right. Where is my chip? Is that it? I think that's it. Okay. WinBond. We know this is a programmable chip because it has a paint mark on it. And that's usually how the manufacturer identifies any chip that has some kind of firmware on it. Not everybody does it, but EVGA bothered enough to do so. So I'm going to go ahead and put my oscilloscope into roll mode so that every time I touch the probe, you see these little spikes. And so let's check in the data in pin. You can see that? That's pin number 6. I think that's the data in. We'll find out one way or another by turning on the computer and watching for any pulses. Okay? Right there. I hope you... let me scale it up a bit so it's be a little bit more interesting to see. Let's do it again. Yep, there are the pulses. And these are basically communication signals. So we're now getting... the motherboard is trying to talk to the BIOS chip. But does the BIOS chip talk back? That's where we check the pin number 2, which is going to be data out. And if we have communications going back, yes it does. Good. That's exactly what we want to see. So with that there, I can safely assume that our card is fixed. But for whatever reason, this very moment, I have no doubts that it would work. So let's go ahead and see if we get a picture. One beep. Beep of success. The monitor lights up and we have a picture. Oh, and we're booting into something we don't want to boot. Some kind of a G partition thing. I don't know. Who cares? Let's turn it off. Let's pop in the Windows loading hard drive. One more time. Alright, so if we have a picture, that means we don't have any problems with memory. Or at least, nothing major. Otherwise, there will be no picture. So let's see if the drivers will be picked up automatically. That seems like a good idea for the drivers to pick up automatically, but once in a while we run into a problem with reporting incorrect TDP percentage, particularly when it shows it unstable. That's where you want to reinstall your drivers clean. I don't think we're going to be seeing that today, but let's go ahead and check. Alright, so this is our EVGA 1080 Ti, 11 gigabytes, GDDR6.5, lots of sensors on all sorts of memory chips. Amazing technology back in the day. So our clock are okay, our TDP is almost idling. 100%, 91%, 100%, 99%, 93%. Jumping from anywhere from 93 to 100, that's a good working value. So we're just gonna power it off. Assemble the card. Let the customer know that it's fixed. I will have to fix a couple of thermal pads in here. And I hope you guys have learned something out of this video. I myself had never seen a failed oscillator. But today I was able to not only identify it, fix it and to teach you how to identify it. I hope you guys found this video helpful. Please hit me with a like, maybe subscribe if you like my content, and comment below, and if you have any questions, let me know. I always read the comments, so be sure to say hello or whatever. Goodbye.